Good morning everyone, my name is Arianna Piccolo and I'm a PhD student within the University of Nantes. The project is funded by the European Union under an innovative training network called FINES and takes place within ANDRA, which is the French National Agency for Radioactive Waste Management. ANDRA plans to build an underground repository center called CIGEO, where long-lived radioactive waste will be hosted in circular section structures similar to tunnels. These will be high-level and intermediate-level radioactive waste. The intermediate level will be hosted within concrete liners of about 10 meters of diameter, where the cells for high-level waste will be about 1 meter in diameter and with a metallic liner. As by law, the radioactive waste must be retrievable for at least the first 100 years. It is necessary to monitor these cells in order to help maintain the safety of the waste and the surroundings. One important parameter to monitor is convergence, which is the reduction of the section of the cells. Standard convergence monitoring methods employ sensors which are put inside the section of the structures and therefore are not suitable for this application, because they will take place of radioactive waste and also they will be directly affected by harsh environments, namely radiation presence, high temperature up to 90 degrees, and hydrogen. As an alternative, it is possible to use optical fiber sensors. As they are tiny, as my hair, they're really flexible, they're made of glass, so they're intrinsically resistant to harsh environment, and with the light that propagates inside, it is possible to retrieve many points of measurement with only one sensor. Optical fiber cables measure strain all along their length. Therefore, they can be applied to the structure to measure. However, convergence is a radial measurement. We want our radial values. In order to do so, we built a method based on inverse analysis finite element method, which is able to translate strain longitudinally along the fiber into convergence, and so displacement in the radial direction. We built a mock-up of the high-level waste repository cell in order to prove this method. This mock-up was charged in the vertical direction in order to simulate the convergence and what will happen in a real case scenario. We instrumented the external surface of this mock-up with two anchoring of an optical fiber sensor cable. One anchoring method relies on gluing the cable and the other of soldering punctually the cable all along its length around the mock-up. Strain measurements which are acquired by these cables are then translated into convergence measurements. These results are then compared with standard techniques for convergence measurements. For example, in this case, we employed some displacement rods, which measure directly the convergence while placed inside the section of the structure. Also, the mock-up was instrumented with force sensors, which are able to give the force which was applied to the structure thanks to the reaction frame you see in the image. In the image, you can see the comparison between all these techniques. And also you can see that convergence, which is obtained by optical fiber cables, is really close to the measurements taken with the displacement sensor, which is in this case is the reference. In this case, we were able to prove the feasibility of using optical fiber cables to measure convergence and also to reach the representative value of convergence that is foreseen by ANDRA for the high-level waste repository cell, which is the 10 millimeters of convergence. In this test, we were also able to reach the 1 millimeter resolution, which is the resolution which is expected within this kind of application. After the demonstration of the feasibility of the method, it will be applied on measurement taken on-site, for example, of the mock-up of the intermediate level long-lived radioactive waste cells, which are already built in the underground laboratory of ANDRA in Bure. Along these studies, it will be important to analyze the impact of high temperature and radiation on the optical fiber and, mostly important, on the cables. Despite the necessary further investigation, the results obtained up to now are really encouraging in view of using optical fiber sensing cables for convergence monitoring, not only for standard tunnels, but also for special application in harsh environments as for ANDRA and CIGEO.